Hi, Christian. I assuming that Christian is pronounced perfectly.
Yes, Christian's fine. Thank you. Hi.
Christian, even, right?
Christian in German, yes, that's the proper pronunciation. But Christian is perfectly fine. Everyone calls me Christian in the office. So.
Okay. What was your first computer?
Oh, 286, I think 96, 94,
Wow.
95, 96, yes, something like this.
And what you did with it?
Gaming, things like Captain Comic, things like, well, there were some text adventures in DOS you could play, I could modify, but I really didn't have a clue what I was doing back then. So I was just editing the text of existing text adventures and made my own. So, but very basic stuff. Yeah, my dad was, when I was 7, he started to track everything in Excel when it came out, because he did this in his job. And so we got all into the computer world very early. Yeah.
Okay, but the text adventures, which games were they? You remember?
I don't remember them, but they were like source code based. They were basic based, so you could modify them. You had the source code, and that was pretty neat. Yeah.
And you also mentioned the Captain what? Captain Comic?
Captain Comic, yes. It's one. I
never heard about that.
But Civilization, like this was also the first one, right?
Okay.
That's one you played back then. Yeah.
So how the transition happened from Captain Comic to Visual Basic, I guess?
Well, I actually didn't code for quite a while until I've gone to higher school, where I learned a little bit of C and Java in the first year.
But in the first year, Java?
No, not really. But no, we also did Basic back then. Sorry, yes. So first year Basic and yeah, but I dropped out of that school because I had some personal problems back then, and then I looked for an apprenticeship, and that was actually extremely hard because I had to. So the job market was not very good.
So you didn't like the teacher?
Well, they didn't like me, so I think.
Oh, really?
Let me go. So second term, I wasn't really attending anymore. So I had like other things to do. I drifted off into computer gaming addiction. I played a lot of Counter-Strike, and at some point I didn't go to school anymore. And then, there was fundamentally a personal reason behind all that.
Counter-Strike against teachers, right? On the other side.
Yes. No, with that. Yeah.
Okay.
Yeah. So after that, I found I actually was looking for a graphics designer position as an apprenticeship, but then I was coming to basically my aunt was dancing with my future boss at the wedding and told him that I'm looking for an apprenticeship, and then he got me in. And then they gave me a week of technical start, and then he said, yes, yeah, but they are an informatics company, so I also need to do informatics. So I also need to do media design and informatics. And so the first year I did media design, and my guide there did see what my skills are in graphics design. So after the first year, I didn't do any graphics design anymore. It's just informatics. So my first language was actually Flash, the real language at ActionScript.
You understood Flash?
Well, Flash is very easy to get into because you can click everything and you can do keyframe animations.
Yeah, exactly. Yeah, but yeah. I knew Java and I really wanted to learn Flash. But yes. What I remember is you could only write code in the keyframes, right?
Yes. I mean, there are also, you can attach code to objects, and it's
this
really
is what I never got, where is the code? So I tried, like, okay, this is really strange. I would like to see the code, but it was only on certain places. So it really, I tried hard, but I never understood. I mean, I wrote something, but just, some listeners to events, but nothing else, right?
Yeah, it was really easy to get lost and lose the code because you couldn't find anymore. You needed to remember where you attached the code. Yes. That was one of those things. Yeah. No, it's also one of the reasons probably this didn't really pick up. I mean, they also missed an Explorer where you could organize all these things. So it got really big. It was very complicated.
Yeah, very good. But so after years, I found out I was not actually stupid. It was really hard because I always wondered it has to be a way. Everyone does Flash, but I couldn't find the code. So
yeah, so I think this is how you start in Flash. But then there are these pure ActionScript projects where you basically construct everything from code, and this is where it works better. I've never gotten into this stage basically. So because after a year of Flash, and when I switched to computer science, the company was switching to GSP pages, and this is where I got into Java.
J or G?
Java server pages.
Cool.
Like the first one, yeah.
Because after Flash, there was ActionScript, right?
Well, no, Flash and ActionScript is the same thing.
No, but it was possible to write ActionScript first. I remember projects, 2008, and they used ActionScript as the main language. And there are lots of frameworks, and this what I understood, because it was like Java, but it was not Java. And I think ActionScript was supposed to be typed JavaScript back then. It was, this ActionScript was JavaScript 3, I think, and it was almost standardized that the JavaScript was supposed to have types, and now it maybe even happens after 30 years or 20 years. But this was interesting, and I never got the idea why you have to use ActionScripts, and I think all the projects died. But there was Adobe Thermo, I think, and the main ActionScript framework, I forgot. What was the success of Flash? You remember? There was a name. Flash was gone, and the next one was not Flash. It was there was a serious Adobe project where you can actually write code with Code Explorer, and I think even it was Eclipse-based IDE.
I lost track after I switched to Java. Basically.
Yeah, I would have to look it up. Just the name. I think it was ActionScript, maybe just ActionScript, but there was a product. Okay, so but you are reasonable in JSPs, and I actually still like JSPs, but the problem is what projects did, they put too much code, too much business logic in the scriptlets. This is the problem.
We didn't make all the mistakes you do when you don't know anything and don't know best practices. So we put SQL directly into the JSP pages. And so we basically mixed and matched everything up, and we didn't have a proper structure. You don't have proper error handling. It's very quickly gets disorganized. So a little bit of abstraction is actually useful also for JSP. And but these days, I think it goes a little bit off the rails sometimes when you do persistence mapping and stuff like that, which we also did later on.
It was Adobe Air and Flex.
Oh, yes. Flex. Yes, I remember. Yes.
Yeah, this was the name. So now I'm on track again. Exactly. This was a huge hype. And of course, everyone asked me why I'm still doing Java and not Adobe Air and Flex and ActionScript. And And
people ask you that?
Back then.
Oh, back then. Okay.
I always get the questions, why I'm still using Rails and not Java, and why I use Groovy or Scala and not Java. And I was lazy. I stick with Java, and Java gets better and better. It is actually good, to be lazy.
I agree. Java gets better and better. But I have to admit, when I started first with Java, it was Java 1.3.1, roughly.
Mm-hmm.
I think you started a little earlier than me, but that was my first version. And my first experience was just building up a Swing application. And coming from the ActionScript and Flash experience, where you just basically you start and things pop up, right? And in the Java one, it took a minute to boot. And I didn't understand how people could use it back then, right? I mean, that was also
what
way
you used
before.
back then? WebSphere, the Visual Studio, or what you used to?
I don't, but I think... Was it already?
JBuilder, Visual Studio,
either NetBeans, JBuilder, something like this. I don't remember.
Okay.
Yeah. I switched IDEs quite a lot back then, I think.
Yeah, me as well. Mm-hmm.
Yeah.
Okay. So back to you. So you wanted to be a medium design guy, and it turned out you are not skilled, right?
Well, a little bit I'm skilled, but I think I like the feeling for color, for example. Okay. And every time I made a design, I just couldn't make it right. It's and you need to admit if you're not good at something. And maybe I don't see the colors also. It's also really a physical thing.
But colors is math, actually, right? So they are actually if there are rules. And by the way, design is also math. I was really curious. Is it possible to be a good designer? And all the everything, to my understanding, comes from typography. And everything is about having spaces between the elements, and if they are consistent, you are actually already okay designer. But if you know how to break the rules, you are a great designer. So, and this is what my understanding, right? So
that's exactly right. But it really takes a while until you get to the point where you can break the rules in the right way without being like painful. So
I was even breaking the rules without knowing them. This was even worse, right?
So my partner is a graphics designer, and sometimes I still show her some things I make, and she's like, "Oh, this is painful. You shouldn't have done this." And it's like so clear for some people. It was not clear.
Can she explain why? So she say this is painful because, or she just knows that it's.
She knows what to fix. Exactly why it's hard to tell, right?
This is what interests me. Why they know. Right, so this is exactly.
I mean, there are rules, and you learn them, but they get so ingrained into your brain that at some point you don't think about it anymore, I think.
Okay, well, similar to programming a bit, right? So you know when the code is simple, and if it's simpler, then you see, okay, this is bad code. So this is also a fine line to walk. Okay, so JSPs. What you did with JSPs? In Linz, I guess.
Yes, in Linz, in a small company that did point-of-sale systems. And I think we were really early doing like web server applications like this. This was the time when so the problem with point-of-sale systems is that you need to attach hardware to it, right? And that used to be impossible because you didn't have, in the web, you didn't have access to that. So we started with ActiveX components, and then at some point we could do some more advanced, I think we also switched then to Java applets to address the hardware, but it was all very rough. And back then you could really see the glaring security problems of Java applets when you used them, because you could just access hardware without user approval, right? So this was back in the day. Yeah. These days it's not possible, of course, anymore.
Yeah, Java was very good with integration, right? So.
Yeah.
But what's interesting, right? There's Linz is like a Silicon Valley of almost Europe, not only Austria. This is amazing how much happens in Linz, right?
Yeah, I mean, it's also because GraalVM was born there, right?
GraalVM, Dynatrace, lots of companies
Dynatrace,
in the tobacco, factory. There are lots of startups right now, so it's an interesting place.
Yeah. So. We did this Java Server Pages application. It was kind of a repair manager, so you could track repairs and then handle those. And then at some point, the whole thing changed. So the core application, what point of sale, was not written in Java back then. That was written in I forgot it. Some 3GL language. Wait a minute, I forgot.
Power Builder.
No, but something in the direction, much less, much more obscure.
Okay.
But actually, it was not too bad. So you could write, it had a good SQL integration and things like that, and the whole application was thing. And they brought in a consultant, or a few consultants, and they basically did a big bang rewrite in Java of the whole point of sale thing. And that took obviously way longer than everyone expected, and I had like huge architectural problems. I mean, again, also best practices were missing back then, I think. So we started off again bringing a point of sale into the web, and so we rewrote the entire thing into web with Java server faces was the new thing back then.
Okay, which server you used back then? Glassfish, Payara, Whitefly, JBoss.
I think we just ran that stuff on Tomcat. Most of the time.
Tomcat,
yeah,
okay.
Yeah, if I'm not mistaken, yes. Yeah.
The funniest Tomcat stories from back then, I know funniest, this was a regular stories. People say, okay, we use Tomcat, we have lightweight applications, so as Tomcat is small. Yeah. And I ask, and how big is your war? And I think the largest was 500 megs. And I said, okay, I would say, okay, your server is lightweight, but your application is, not exactly lightweight.
No. Exactly. Unless there is like a lot of resources in there that's served. Yeah. Right? So that can of course happen. It's fair.
And you were happy with the project so far?
No. The thing is that the web is not a good platform for point of sale system. It's not reactive enough. And also the hardware thing was much harder than on a regular desktop thing. And the other big problem we had is in point of sale, and back in the day, the internet connections were not as stable. So basically, they invested a lot of money and technical effort into replication. So basically, your shop could still sell stuff even if you lose the connection to the server, right? So, so basically, every shop had a small local server with a database, and then every day through replication, the sales were basically replicated to the Centrum server, right? And that model doesn't really work in a web. If you have then need to switch servers for the thing that serves your local pages, maybe that would be possible. We would have a lot of redundancy. So we basically abandoned the GUI thing, the web GUI, and we've gone to Swing GUIs. And this was also very interesting because I was actually developing the first Swing GUI there. And
which year was it? Which year, you remember? 2000 and what? 5, 6?
2005, 6, something.
Okay.
2005, 6, yeah. And this was the advent of touch screens, which was also really interesting. But this was not the good kind of touchscreen you're used to today with multi-touch stuff, right? Multi-touch was not in the regular big touchscreens yet, right? So they were all single touch. So you press two fingers on the screen, and the cursor goes in the middle of the two fingers, right? So this is the kind of touch.
Oh, didn't you? Okay, this is okay.
Yeah. So not the modern ones. But still, they were coming up, and they were all very popular in point of
So this was like multi-touch with additional calculation, right? So this is so...
well, not really. It was just the physical limitation of the thing, yes. And the cool thing about Swing is their look and feels. And so you could write a different look and feel for the same GUI.
Yeah.
And that allowed you to transform a regular GUI that you use with a keyboard into a touchscreen one, with just changing the look and feel. And this is what I developed back then, which was really cool. So I could develop my own look and feel, and then upload up the buttons to the right size. And there was special layouts that made it so that always looked reasonable. Wasn't always perfect, because if you have an abstraction in between, then it's always hard to balance those things. But in the end, I think it worked out really well.
A napkin look and feel.
Yes, of course. My favorite was MIG layer.
Didn't you? Substance was my Substance.
Okay.
Substance.
So maybe that came late. Substance was later. Substance was the fancy new thing with the new borders. We switched to. We basically forked Substance and made it our because the design was just nicer and was very close to what the graphics designer back then designed.
Okay.
I had really big beefs with the graphic designer back then, because there was a designer that designed the whole interface, but he wasn't caring about accessibility at all. And so we were fighting all the time. So he basically used really low contrast font colors. Oh. And so you couldn't see and read the text anymore, right? And I told him, that's not something you can do. It looks nice, but it doesn't work, right? Mm-hmm. Because like point of sale systems, people are working with it every day. So in the background, like we rolled out this point of sale system in 2002 in Germany, entire thing. And the mobile providers, telecom providers. And people back then called us Disneyland because the new GUI was so colorful. And,
cool story, actually.
Yeah. So this is always funny if you put out some new software, what people that actually use it. I never talked to these people, right? There was always people in between, and I think this was a mistake too.
Yeah, absolutely.
You need to get the engineers close to your people that use it.
Yeah. I worked for a larger company, and the designer measured whether the design was rightly implemented with just measuring the screen, right? So he had a rule. And measured whether it was correct. And I say, look, this depends on the screen. It depends on dimensions. But he wanted, to make it right, and everything had to be pixel perfect back then. And it worked because I still remember it was 1024 by 768, 68, right? It was the dimension. Then it worked correctly. But if it was a different dimension, different screen, it didn't work. And this was hard to explain to the designer that actually it only works in one dimension. So this was funny times. It was a little bit earlier. It was like 2002, maybe.
No, I think designers that insist on a pixel perfect execution, that don't understand the technical limitations, that doesn't fly. Because designers also don't.
This was very common back then.
Yeah. I mean, for receipts, we had to be pixel perfect. Yes, I remember that. Like we also had a receipt designer. We used Jasper. Remember that?
Yeah, Jasper.
Jasper reports. Yes, that was pretty cool actually. I like that.
Yeah, cool project you did actually. You use NetBeans, Matisse, for the UI design?
Yes, I think I used NetBeans for a while because of it, because it was such a big step forward, in how fast it was. But then I think I went to the Eclipse one, this visual thing.
Yeah.
And the cool thing about that one is that you could switch between code and GUI much easier. And if you had already existing code, it could still render it reasonably well, right?
Okay,
because
cool.
it actually was executing the code you were running, which also had its problems, right? Because if you do complex stuff in your GUI code, then it doesn't really render very well. So you had to be a little bit disciplined about how you separate the code from. But it worked really well, I think.
What I did with Matisse in larger project, we introduced Model View Presenter, so we were able to separate, the generated part from our controllers, and it also worked. So it was also good.
But could you take your own GUI that was not written with that in mind and then render it to your screen?
No,
right?
No.
Exactly. That was the problem with Matisse.
And sometimes it become corrupt, so you have to reverse the last step. But it was It was still fast, but it was not perfect, of course.
Yeah.
So what happened after the project? Or was the project successful? It was, obviously, right?
Yeah, I mean, like lots of other stuff I've did after that.
What was it as roughly? What was the use case?
The use case is point of sale software. So you basically at the shop, you sell stuff, you scan barcodes, and then you go to the terminal and then to make the account balance, right? And actually, I was responsible for a lot of different components. I was mostly on GUI. Then I also did the hardware, the first version of the hardware connection. We used third-party drivers for that mostly. So we didn't have to do a lot of work there, but we still need to do some native code. There was actually one funny bug I had, like the worst bug. I talked about O2, right? We rolled out there. And I wrote this workflow framework. It's like basically a step function-based workflow thing back then, which I'm still a little bit proud of because other people are still big companies doing this today as well. But I just came up by myself.
Is it open source?
No, it's that. It's also always was proprietary, not the framework that was published. But so basically, I needed to suspend the workflow at a particular location. And when the workflow was running in GUI mode, I used the JFrame AWT hack to suspend it and then use the even queue to run something on top of that. Right? It's like a really nasty trick. Don't do this at home. But also, I had to, for some reason I don't remember, I had to spawn another thread to do some side work. It's full of hacks. I'm not proud of that. But it happened. This other thread happened to invoke the workflow engine for the caching twice in production. So basically, the hardware thing that the workflow that basically handled the sales was like going to the remote thing and basically every receipt was cached in twice, right? Mm-hmm. For the worst possible case, because customers are cached twice. But luckily, that was out for a few days until the central center for the receipts noticed, hey, there are like double bookings all over the place. And this is where my boss came to me and was like screaming. But he could fix it all. But I think this is the worst case because you lose the.
Did he really? He was screaming?
Nah, I don't think so. But I was like really, really nervous.
Yeah, okay. Yeah. Yeah. But it was maybe easy to fix because every receipt had own receipt ID or something, right? So you could actually fix that.
No, I think the workflow was actually getting new receipt IDs for the thing. So that was not sent over. But the balances were all the same, right? Exactly the same. And they had a detection for exactly that case in place, which was good for me or for us back then to protect.
Yeah, and this was you're now famous at O2, right? Which does
no, I'm not famous, but maybe the bug is still famous. I don't know.
Yeah, okay. Disneyland bug.
Yes.
Okay, so it was actually popular software, right? It was shipped in lots of stores.
Yes, we had quite a few customers, especially in telecommunications.
Cool. Crazy. What happened afterwards? Were you fired after the bug, or what happened?
No, so I was I did other stuff. I was also involved into translating, so multi-language. So basically, I also wrote the framework that the GUIs could be translated automatically, and then also you had these keys that way before there were real proper frameworks for that. And then you had a own module called the translator that showed it properly, and then you could save your translations to the database, and you can pick it up from property files. You can send it out in a nice form to the translator, import it back, and things like that. Also, and I did an Arabic layout for Swing as well, so you could basically translate everything into the other order because we also had Arabic customers back then. Hebrew as well.
So layout manager, you played.
Yes, yeah. I also did it through the look and feel, and basically like that. So at some point I got bored, and I came up with this super crazy GUI framework idea because you have a GUI application, but you always need to run everything locally, right? Mm-hmm. And you need to have the database connection, and you don't have a server connection. So I wanted to introduce a mid-tier thing for GUI applications. So I wanted to marry best of both worlds, right? Mm-hmm. I wanted to have Swing application, and then the background beans are basically serialized to the server. And it was using Java object serialization. Yeah. And you had to be extremely disciplined to use it, and obviously not a useful framework then. So I made a lot of claims to to the boss back then that I can now have the best of both worlds. You can disconnect it. You don't need to have a database connection in your clients, and you can still have the latency when using it like a Swing application. And I was using object graph serialization, and as you can imagine, that gone really bad because the boundaries were not working properly, and it was just not the right abstraction.
So what you wanted to do is to capture the presentation state of the application sent into the server. So it's just okay. Mm-hmm.
I was just basically doing Java server faces for Swing, just worse.
Okay.
Yeah, so something. So
but you had to have your own graph first, and you serialize the graph sent to server and reconcile both states, right?
Yeah. So basically, you built your own server-based components that you could then show to the client, but the code for the components were actually running on the server, so it was all controlled on the server.
So like Oracle faces, right? Oracle, not faces, ODF framework. They are able to render JSF to Telnet, for instance.
Yes. But I mean, this is based on the web, which was easier. For Swing, it was harder to do. And you also wrote
ODF, ADF, active data.
Yes.
Active data faces, ADF. This is from Oracle, the framework, and I know they had point of sales. Exactly. You should know. This is ADF, yes. Right?
But I don't know. I'm working on
I don't know whether they're still around, but it was back then. And what they did, exactly. You're Oracle employee, so I forgot about that. But they had own JSF implementation with point of sales, which rendered JSF to the point of sale, whatever. So this is an interesting, actually, solution. Uh-huh. And what's the name of your framework? Was it open source? No,
it was just closed. But then there was an economic downturn for the company, and they basically said, we don't want to fund your framework anymore, also because I couldn't properly deliver. It was just basically a mess to develop it. I'm not proud of that. I made a lot of bad choices.
We can cut it off, maybe.
But I think the problem was that the boss back then was technically not the best, so he didn't fully understand what I was doing, and I just got so much leeway, which was completely irresponsible in my opinion, because the focus should be on the user and improving the experience for them, and we did not focus on that at all. We always were focused on the technical aspects of the background. We wanted to go microservices and all that stuff.
Yeah, but it's very common. I mean, this is even now still there are companies who know. Back then was actually, if you started a project, which most consultants did, they wrote started with a small configuration framework in case you need it. Then this was done. Then focus on logging a little bit. Logging framework always needed. Caching framework, very popular. And in the end, some use cases for the client. So this was usual after half a year, of framework. Yeah. Cool. So what happened afterwards?
So 2010 came, and I basically quit after that because I didn't want to work in the company anymore because they didn't give me something interesting to work on. And so I made a really good deal with them so I could basically be working for them a little bit and then start studying. So I was going to university at JQ in Linz, and I started studying. And in my basically, since I already had a lot of experience Java developing, and JQ Linz, the computer science classes are all based on Java, I had a really good head start on the coding part. I was really struggling on the math part because I had basically zero knowledge there, and took me a lot of time to get into those. But I managed to, but ultimately. But the first term I was at the university, I was doing a software development 2 class. And in the exercise class, the lecturer was actually Thomas Wittinger, my now boss.
Yeah.
And I was asking a lot of annoying questions during the exercise. So after the exercise, he ultimately asked me whether I want to become his tutor to correct his works after that. And he was younger than me. He's like this super kid that just skipped a lot of classes, and he did his PhD in no time, right? So he was
nice. He was a nice teacher, or
he was a nice teacher, but he also said from the beginning it's going to be a different kind of class, and it's going to be a little bit more demanding and faster. And he switched IDEs every single class, so every exercise different IDE. And he did a lot of this crowd development back then, where he just asked the audience, "What should we do?" And then we did together a program, and then we worked on it together. It was really educational. I really loved that. For me, it was really good. Others that were earlier in the thing had a little bit more difficult time to keep up with the speed because it was quite fast. Yeah.
But sounds like a great teacher if you're interested to learn, right? So
yes,
okay,
indeed,
cool.
he was. Yeah.
Yeah.
And then I was tutor for him, and then at some point he asked me what I'm doing for my bachelor thesis, and this is how I got into the GraalVM project. And this was when I think this was 2012 something. Yeah. This is where when Christian Wimmer, Thomas Würtinger, and Doug Simon were architecting the early stages of the Graal compiler and also Truffle. And this was way before native image even existed.
Yeah.
So that also came later. Yeah.
And what you did as the bachelor?
So the first bachelor thesis was a Java interpreter in Java. So the idea was to explore I need to take a step back.
It's almost espresso, right?
Oh, it's espresso, the first version, I would call it.
Okay.
There were several versions of it, and I will get to them, I think. But there was the time when Graal needed a framework to expose the VM internals to actually do compilation in a Java using Java, right? So Graal was already written in Java. It was a spiritual successor from the Maxine project back then, like this Java virtual machine completely written in Java. But that was a bit too heavy on the abstraction, so it wasn't really taking off. So they said, "Oh no, we're doing it the right way now," and we learned from this, and he did the modular Java compiler that was based on C1 actually. It was called C1X in the beginning. But yeah, so there was this old framework called JVMCI, Java Virtual Machine Compiler Interface, that was in its early stages back then, and that exposed all the internal details, methods, metadata from the VM as Java objects already. And so it was actually quite easy to write a Java interpreter using these abstractions to just interpret the Java compiler. You still needed some hotspot hacks to actually install a Java interpreter, and that you had like this meta-circular issues. What if that runs? And one of the things I couldn't get to run is make static initialize get interpreted with my interpreter, because then I also would need to initialize my interpreter somehow, and then you get head spins. But what I managed to do is then to run the Java interpreter on my own Java interpreter in the end, without the
This is why it should be Project Matrix, like the movie.
Yeah, it just got it's Inception, right? You go deeper and deeper.
Inception as well, right?
Mm-hmm. Yes, yeah. And it becomes obviously exponentially slower, and that's what I proved in my bachelor thesis, and that's. But I think it was also a proof of concept for can we build other VM components in Java besides the compiler, like the interpreter.
Can be other components besides the interpreter in Java. So what I couldn't understand. So what do you want to prove that you could write Java in Java and what?
No, so the proof was, the Java in Java, the meta-circular thing came actually afterwards. But the original idea was to just see which VM components we can write in Java. And
which VM component you can write in Java. Okay.
Yeah. And the interpreter was not ever tried in Hotspot, and so we did that. It's a safe language. It has its limitations. And
the interpreter, you mean this is which interprets the Java code to bytecode, or no? No, not bytecode. No, it interprets the Java code on the fly and then decides to machine code, right? This is the pre-stage where the decision is made. Is it going to be interpreted or JITted?
So there's the pure interpreter. So there's the Java compiler, which takes the Java source code to Java bytecode. This is not where this is. So when you talk Java compiler, I always mean the Java bytecodes to machine code. This is the Java JIT compiler. That's what I mean with that. The interpreter takes the Java bytecode and executes it in a loop and interprets it. Basically, does a big switch dispatch on it.
This is what you worked on.
That's what I worked on as my bachelor thesis.
And you implemented the interpreter in Java, right? So this was the idea. Or
yes.
Yes. Okay. So prior to the interpreter, which took the bytecode and either run it or created it ran the bytecode, was written in what? In C? C++?
Yeah, so the hotspot interpreter is written in C++, but also with, back then, with assembly templates. There were multiple versions, one slow one, one fast one. I think there are still multiple interpreters in hotspot today.
And your job was to replace parts of the hotspot with your Java?
It was to try.
To try.
Okay. Yeah, it wasn't really something that we could productize at the time because the frameworks weren't ready.
So the project is maybe JHotspot would be, right? So something like this.
Yes, and this was kind of also Maxine, and that failed. So we started to do something. A compiler has a huge advantage to other VM components because it has a very clearly defined interface. So a simple one, right? So you take some bytecodes, you say compile it to machine code, and then you get the machine codes back. Very primitively said. There's obviously more to that, but the interface is much simpler than most other VM components. And the idea for Graal in the beginning was to write a modular compiler that you can actually compose with phases and stuff like that, right? So this was not common back then.
I had a chat with Thomas, and what I remember from early Java 1s, James Gosling introduced the idea of Project Maxwell.
Yeah.
And this was the first idea, and it was somehow renamed to Maxine. And then you are working, already in the third version of that, which is actually pretty cool, right?
Yeah.
And okay. And if you do it in Java, this is the meta part now, because the Java, which interprets the bytecode itself, is of course has to also be compiled and interpreted, right? So this is like, and this is where Inception happens.
So basically, you have you have some bytecode that does system out print line or just assigns a field. That was my benchmark back then, assigning a field. And then you take the interpreter, interpret the bytecodes of assigning a field. And then you take your interpreter to interpret the interpreter that interprets the assigning the field. Right? Mm-hmm. This is where, and then you can stack this as much.
Mm-hmm. And the idea is, of course, that if we have the knowledge of the real hotspot, everything gets more and more optimized, right? So in one point of time.
Yeah, no, there was no production use case. Yeah. This was just for fun.
So you managed to complete the university with Thomas' ideas and your.
So that's actually a fun story because I was a quite heavy smoker back then. Basically, smoked a pack a day. And this was in the early days for Truffle framework. And
so GraalVM is not necessarily good for your health, right? So this is
no. I started smoking when I was younger, right? Was difficult time. And Thomas was in the early stages of designing Truffle. And like, how could we really do the partial evaluation part? It wasn't so clear. It's not like we wrote the articles on Futamura projections and then we realized that we can use this. No, it was like we also came to the same conclusions as Futamura projections. Thomas came to the same conclusions. And so he invited me like once a week.
Which projections? What is the name?
Futamura projections. The thing that is Truffle based on. We can go to it later.
Yeah.
And Thomas was inviting me to this course where he was designing it, and I was pretending that I could keep up with him. And so we had these like 4-hour conversations. You know how hard a 4-hour conversation is for a heavy smoker? So after 3 years studying at university and working then at the institute, the Institute for System Software at JQ, I had to stop smoking because I just couldn't do this anymore. And actually, it was not the only reason, but it was one of the main reasons I stopped smoking because I got so pissed on my addiction that I couldn't do these 4-hour meetings anymore. And I really enjoyed those meetings back then.
So Thomas is not compatible with smoking.
No, and he was not like if I would have told him that I need to go for a smoke, he wouldn't understand. Like, but why?
Exactly. So,
yeah.
That a cool story actually. This is actually the best story ever, right? So Thomas is good for health.
No, not always. He had this extreme time where he got all kinds of mountains, and then he almost died several times. So don't follow him blindly. Yeah,
but he looks so innocent. This is the problem.
Yes. So back to Espresso version 2, because then we actually started another Java.
But wait a second. So you completed your work, right?
Yes.
Quit smoking, and then you joined Graal.
I already joined Graal before I stopped smoking, but then on the time I did.
Okay. And then the first version worked? And how well it worked? I mean, what worked and what didn't? I mean, was it like general purpose?
Well, I mean, it was. I think back then we had the problem that the Java compiler was written in Java, and it had to be compiled. It's stitch compiled itself before it can actually compile fast, right? Yeah. So you have again this problem of meta levels, right?
This is how the Inception movie happened. I'm pretty sure they also worked on the same stuff, right?
Yes, they worked on GraalVM for sure. And also we had this other problem and Oracle project coming up, which was called MLE, Multi-Language Engine for the Oracle database. I mean, as you know, for Oracle, this was already a research collaboration with Oracle, and everyone was very proud at the Institute that we had this huge, long-going research collaboration going back to Sun, right? Sundays, that's where it started. And
Emily happened from Oracle, you said. And
So Oracle MLE happened, yes. And then we needed to get a Java application into the Oracle database. And we couldn't quite, you have the same problem, right? You need to take a truffle interpreter. Back then we started to develop GraalJS. That was the first truffle language we developed. And we wanted to get it in the database and not have all the downsides of Java in the database. And
GraalJS, funny story, interesting story. Yeah. I tried GraalJS very early because I use Nashorn a lot and I need a replacement. Yes. And then I replaced Nashorn with GraalJS and forgot about that. And I set it globally. And I worked a lot with web components. I need sometimes, Node.js and sometimes whatever. And at one point of time, after 1 year, something happened in my build system. And I took a look in the terminal and I saw a Java stack trace. It's like, how is it possible? I mean, why? I mean, I'm just running JavaScript. And for 1 year, without noticing, all my web stuff was based on Graal. So compatible was it back then. It was a long time ago. It was like, I think prior to pandemic. And this is incredible. So I worked, 1 year on GraalJS, run all my stuff on GraalJS. GraalJS is the name, right? It's GraalVM JavaScript. Without noticing that. And kudos to that back then. And now it's even more compatible. Back then, it was really the nicest error ever. This was not even fault of GraalVM. Something happened with the build system. And what I also evaluated, but it was, I would say 1999 maybe, or the 2000s, around Aurora in Oracle. So Oracle had an own JVM, so you could run JVM in Oracle, set procedures back then, but it was slow. But it was the old, this was the Aurora VM, I think was the name. So this is what...
That was exactly the mistake they didn't want to make with GraalJS, bringing GraalJS into the database like this, because they had made really big problems with updating the versions because it had a global class loader and you didn't have instancing there, right? So you really couldn't run multiple Java applications because they were affecting each other. And it was, I don't know too many details, so I don't want to...
Yeah, sure.
But so we needed a new thing. And this is how Native Image was born. Basically, Thomas and Christian Wimmer back then, they sat down and understood how can we make Java applications deployable to the database. So, and then they figured out, we need to do closed world and AOT compilation. And that was the birth. And that's what a lot of people don't know where Native Image is coming from. It's really coming from the idea of bringing GraalJS into the database, so the truffle language. So basically, supporting GraalJS runtime compilation was always a major component of the Native Image runtime, which is called Substrate VM. And the idea was to really reduce it to the smallest possible thing. So you have just native code there that has almost no memory, there are no Java bytecodes left, just native code running, and no class initialization left. And a lot of these decisions from back then are still kind of propagating to today, because people are struggling when they use the Native Image tool with some of these decisions we made back then, actually to bring the GraalJS runtime to the database, right? So the design decisions are still kind of visible today.
Great story, because it means the GraalVM has to be battle-proofed, because, running in Oracle database in constrained environment in production is a complete different beast, This is, it has to be stable, and it has to be predictable. And what's I didn't know that this GraalJS was used was implemented for Oracle, which means we can happily run JavaScript within Graal, and let's communicate with Java. This is even better, bidirectional, so way better than Nashorn was back then.
I hope so. There are some debatable decisions that Nashorn made that actually caused some of our users to be a little bit upset with us back then when we switched, because Nashorn made the decision to expose multi-threading to all the users. And then they wrote this blog post about how to use multi-threading responsibly. And we looked at a lot of Nashorn applications back then and how they were using. Not a single Nashorn application was actually adhered to the rules in this blog post. So all of them were exposed to unpredictable race conditions and problems, unspecified behavior from the JavaScript side. JavaScript is just inherently a single-threaded language, so you can't run.
And what I did, you know EJBs?
Yes, of course.
And I never had the problems because EJBs were great for that. So what I did is I had a state as EJBs, and in the post construct, I initialized the context from Nashorn, and it was always single-threaded, because one EJB could be, and the cool story is it was very fast because it had a pool of EJBs, 10 EJBs. I had 10 parallel Nashorn engines, and this worked perfectly. But right now would be harder because EJBs are not used that often. So I will have to migrate to CDI, and there is no pool. Yeah. So right now would be harder, but I don't have the projects right now. But EJBs were the perfect solution for multi-language, single-threaded context, or however you call it, right? So
yes, Today we basically need to do this manually. You do context pooling to use JavaScript instances across threads, right?
If we had EJBs, there would be nothing to pull because they are pulled itself. So this,
If you already have a quite heavy request, then it actually doesn't matter if you create a GraalJS context for each request because it's sped up. It's below a millisecond if you warm it up properly. Then to create a new JavaScript instance.
So you've worked on GraalJS.
I worked on GraalJS. Before that, I was working on the second JavaScript.
Exactly. Why second? Why the first was not perfect?
It was not different. So Truffle was back then and a framework for EST interpreters. So
but Jaroslav Tulach also worked on Truffle, right?
Yes. And you know where Thomas asked me about when I do my bachelor thesis. This was at the end of Jaroslav Tulach lecture in Linz. He was invited. Thomas and him, we were already friends back then because Thomas was working on the IGB project and that was based on NetBeans, and so they had a connection. And he invited him for a lecture for rich client applications. And after that lecture, Thomas asked me whether I want to do my bachelor thesis. It was Jaroslav's lecture. So
I had back then always friendly fights with Jaroslav because he was very explicit with API design and so forth.
Yes, he has very strong opinions.
Yeah, and very strong opinions about modules, but he had to to implement the NetBeans module system. And I was from the business perspective, and we say, who cares about your modules? We never have a two implementation for an interface. This is why I never use interfaces. And he was upset. Like, why? No, I mean, you have to encapsulate. Like, I don't have to. For me, it's a Java class with some public method is enough, And this was the best discussions ever with him. So I have to invite him to podcast again to have a little bit more fight. But and he, because he delivered some talks about Truffle, the first ones, and I was really into it because for me it was like BAS or a meta framework where several languages can communicate, which was unique because you say, okay, if you abstract the data objects and every language uses the same data objects, the same data, then they are interoperable, which was new, right?
Yeah. I mean, the whole interoperability idea in Truffle is born a little earlier by Matthias Grimmer.
Is it not goal of Truffle the interoperability?
No.
Oh,
no.
Then I completely misunderstood Truffle.
It's one of those goals, right? It's a piece of it. So
why you need Truffle, maybe? So you say because
Truffle is a framework, or originally started a framework for building virtual machines or Truffle language runtime implementation. So it's a framework for that. The important idea was actually to get an easy way to get runtime compilations for languages like dynamic languages, mostly at the time, like JavaScript. And this was really hard back then because there were two ways of implementing a language back then. So not Java already did it more advanced, but typically you either had a compiled language, a purely compiled language like C or C++, that is compiled ahead of time just to native code. And then you had the other languages like Python that are purely interpreted, right? Those that never go to native code, they always stay in this interpreter loop, right? And what we try to do with Truffle is to make it so that writing a compiler is really hard, and writing an interpreter is relatively simple. So you're basically very close to the normal semantics, and you just express it using code. Relatively simple.
Yeah.
And the idea from Truffle was to take an interpreter and get the compiler for free. And this is where the Futamura projections come in. And this is basically probably not enough time to go into all details, but you take...
Christian, I will have to invite you back anyway, so we can we
do a session on Futamura projections. It's not Futurama projections, because in the talk I got it wrong once, and it's really bad, and then it sticks in your head. Futurama, don't say Futurama.
So what we can manage... what we should maybe to explain today is why we needed Espresso V2, and maybe as cliffhanger, so the goal of not Futurama, what Futamura projections, exactly. So okay, so what we should do? So truffle. So exactly. Complete the idea of truffle, and the next time we can talk 1 hour about whatever makes sense. But today, truffle, my understanding is like the data between languages, and this is way more. So this was my misunderstanding. So and you said it's a framework to building JVMs
JVMs, building VMs.
VMs.
So
VMs,
the original paper was called One VM to Rule Them All, right? So the core understanding is that there are probably always going to be multiple programming languages, because you cannot fit all the niches with one programming language. There are just inherent trade-offs between programming languages. So we will always end up with multiple VMs, and those VMs always repeat the same implementation details and optimizations for every single VM. So for us, the idea was to take this concept of generating a compiler out of an interpreter, and you only need to write the interpreter, and then you don't need to do all this work to write the compiler anymore, right? So you only do this once, like the Graal compiler, and that's the story.
So you means if you have an interpreter, there is a way to get compiler for free?
Yes. So NAS1 was different. NAS1 was basically having in the beginning, it didn't even have an interpreter. I think it had an interpreter for a while. And then after it was executing a code a little bit, then it was producing Java bytecodes and then feeded that to the JIT compiler. But that compiler was also written explicitly, right? So you basically fed the Java bytecode. This is not how Truffle works. You only write the interpreter with this Futamura projections and partial evaluation, and then you get the compiler for free, basically, if you adhere to some rules. And it translates to, basically, it takes an interpreter loop and then unrolls every bytecode in that loop. And gets to the compile code. That's the Futamura.
And unrolling means if you have a for loop, you can always transform a for loop to a sequence of statements, right? This is
exactly. You just do it very aggressively by assuming that the bytecodes don't change. And that's
you said you had problem with math, and what I noticed actually is I don't know what is higher math, the integrals and differential equations. They are almost programming, right? They are so close to programming that is actually crazy. But my problem with math at the beginning was it was so abstract. I say, okay, so, some crazy prof has no idea what he or she should do, and tell us tales, and I just would like to program. Leave me alone and give me some code, right? But right now, I say even if you look at the entire functions of G for X and Epsilon for X or Y for X or whatever, the nesting, okay, I see methods, I see functions. It's actually, this is also in your case, also the projection, the projection is also math, even if you have the for loop, it only looks strange as a math formula with the crazy inverted E, right? But if I see already the E back then, I say, what is this? And now I see a for loop. It's okay, I see this. It could work, right?
So yes, those kind of math I kind of could get rather easily. Like that was not that hard. So, but the first math class I took was analysis. And what they did from the beginning is they very early asked us to prove stuff. And this is where my intuition fell apart. So normally I could follow the rules and then expand stuff and interpret stuff. And it's just a new language you need to interpret. But as soon as you get into proof territory, you need to apply other things, patterns into each other. You need to know a lot of patterns of proof that you actually can apply. And that overwhelmed me completely in the beginning. I was just completely lost proving anything in the beginning. But I worked really nights to get there. And in the end, I managed to prove stuff. And I was
And you still know it, or you forgot?
I think a little bit, especially the proving part. I think I know what for computers, you also want to prove programs. And that stuff still interests me, and I still read papers on that. So it still sticks around a little bit, but I'm not proving myself anymore. I let computers prove it, right?
Okay, cool. This is the okay. We covered a little bit of the Futamura protection. Yeah.
Yes. Let's move on. So that's the one part, right? That Truffle started with. Get a compiler for free, which is a huge thing. Because it's very hard to write a dynamic language runtime. The core part that is actually hard is the de-optimization part. So basically, you do an optimization. You run in the interpreter. You run for a while. Then the JIT comes in, compiles it to native machine code, and it makes certain assumptions about the things that you've seen in the past.
Mm-hmm.
And then these assumptions fail. So what you need to do is you need to de-optimize back from the optimized code into the interpreter. So you need to reconstruct the entire interpreter state. This is where many hotspot bugs come from, where this de-optimization metadata was not correct. And
you know what this almost is? This is like a back propagation in LLMs.
But
I mean, that's the same problem, because you can go forward is easy, but backward is not that easy.
Yes.
And
information.
And you also said, it means de-optimization means the assumption was wrong. And this is also how LLMs are learning, because they assume this is, but there is a loss function or error, and you have back propagate this to this initial point. And this seems a very, very similar problem, because you're assuming this is fast, but it's not fast. So how slow is it actually? And you have to learn from that and reapply everything backwards, right?
Yeah. And then the profiling is nothing like basic machine learning, right? It's just overused these days. Yeah, absolutely. So that's that hard part, and that part you don't need to worry about in Truffle, because you write the interpreter, and the de-optimization is just calling a Java method. It's called transfer to interpreter and invalidate the code. You can directly call a method, and that's extremely powerful, I think. And people don't only realize this way later in the stage, when they first wrote an interpreter, a compiler, then started to speculate, and then they de-optimize. So you realize very late that you actually need this kind of feature, and then it's really hard to do, right? And then they get stuck. Mm-hmm. So that's a reason why you should use Truffle for your language implementation and get the JIT for free, because those things are hard in the end. Then we also want to get languages, and that's where the interop comes in. We want to encourage reuse across ecosystems. Right? Mm-hmm. So in the beginning, when we went out and this polyglot idea came out, we first did a lot of experiments. Do you actually want to write programs in multiple languages? And the answer is no. This is what we learned very hard over the years, because the mental capacity of the people is not enough to handle multiple languages at the same time.
Yeah, so, very good. Because you remember the conferences, I hated the talks, the polyglot programming. You write write language for the job. I'm like, you are all crazy. I have enough to do with Java debugging.
People, because they can get so many languages in their head, right?
Yeah. Some speakers can, some speakers are speaking about every other conference about different language. But for me, I still don't know Java well enough. This is really crazy. It is really hard to keep up with Java. For me, it's not imaginable, to get another language and learn something. This is just, okay.
So cool. the core thing where we are focusing on is on reuse. So you want to use the JavaScript library that they wrote, or that Java library in JavaScript, and
or Python
these days, and Ruby and all the other languages we support. And you can do this cross, so you can use JavaScript from Ruby and things.
I give you a concrete example. What I use, for instance, the podcast is generated with Java. So I wrote the static page generator with Java. But I needed some templating, and this was before multi-line strings were available in Java. So I used it runs on Graal and uses mustache templates, for instance. Or handlebars.
Cool.
So it loads the JavaScript. JavaScript does nothing about that. I pass my parameters, and it generates the show notes for the podcasts. Yeah. And this is command line interface. Works for years on Graal, for instance.
Cool. Very cool. Yeah. Another one is React, right? React rendering in Java. You can now embed that into your Java server, and then you can make your client people use React, right? No problem.
Oh. Even cooler. You mean the SSR, right? From React is static. Whatever they call it, the React on server.
Yeah, I don't know too many details about that. Focusing on language implementations.
Of course, okay, cool.
Yeah. So the reuse across thing, that's the other thing. So you can use libraries, and then making embedding easier. So and their reuse
means that I function. in JavaScript is callable from Java because both have common type in Truffle.
Yes, in this case, it's actually the Java language is the so-called host language, and the JavaScript language is the so-called guest language. And then you run Python as a guest language, JavaScript as a guest language, and when they interact, they actually communicate via reflection, right? So it's not as efficient. But if you call from JavaScript into Ruby, it's also very reasonably efficient. But if you call from JavaScript into Ruby, you can inline from a JavaScript function into Ruby because they all built with the same system, right? So you can JIT compile a Ruby method into your JavaScript code. And this is what we demoed in the beginning very often is like, oh, you do language interop and there's no cost to it, right? Zero, right? But only if it gets inline.
Because at the end of the day, everything is more or less Java, right? Which runs on the GraalVM.
It's these Futamura projections that make it quite. The partial evaluation is making them compatible with each other to compile.
Because if I would run Java as host and all as guests, at the end of the day, everything, all the interpreters are projected to a compiler, and everything is compiled at once.
Yes.
Yeah, this is what makes highly efficient.
Yeah, exactly.
Is there any other comparable platform?
Yes, there is. In the Python ecosystem, it's called PyPy.
PyPy, okay. This is what I was aware of.
Yeah, so it's slightly different. So Graal is a method-based compiler, and PyPy is a trace-based compiler.
But PyPy is also very old already, right? It's like more
we know the people there, so we are in contact from time to time. So
are they smoking or no? Do you know?
Nobody's smoking in here. Like this is nobody's smoking in the ecosystem here. You don't have time for this.
Okay, cool.
A few people are smoking.
So what we covered, we explained a bit Truffle, and I think we can call it a podcast. And the next time, I would like to invite you back and talk about version 2, right? Of Espresso, whatever we call it, a bit.
Yeah, and then version 3 and
then explain more.
Version.
And one question that interests me: you completely understood Inception movie.
Yeah.
Yeah. And how often you watched the movie once or multiple times?
I think I understood it the first time. Yes.
Okay, cool.
I watched it twice, I think.
Okay, cool. I would say thank you a lot. Where people can find you, Twitter, Blue Sky, LinkedIn, or whatever.
You can find me on Twitter, but you can just go CHUMER.dev. Then all the links are there. You just search my name, Christian Humer, GraalVM. You also find me.
And which what you are working right now?
Oh, right now, that's a big step ahead. So today, we moved away from EST interpreters to bytecode interpreters. So I'm working on a framework called bytecode DSL that generates bytecode interpreters automatically from an EST-like specification and does a lot of optimizations in the process. So I think we can fill another podcast.
Yeah, absolutely. So because right now we have the great foundation, we already had a Thomas, so we can explain GraalVM a bit more.
That's good. I'd love to.
Yeah, perfect. Thank you, and it was fun. And what's crazy? You started with JSPs, and now you are a low-level bytecode hacker, right? So this is this is pretty cool.
Yes, it's cool. Yeah, I love my job. All right.
Thank you.
Thank you. Have a good.